All right, so here we are. So this is a strange section, as I've now said a couple times. Here, can you read it? All right, there we go. Okay. So what are we doing? This section, 3.1, is about proving various little trigonometric identities, they call them. So we're proving things that are true using some of the rules of trigonometry. So kind of like total change in gears here in this section. And I think it's going to be frustrating, just to be frank with you, about the way MathXL does it. It's not ideal. It was frustrating for me because, I know the stuff, and I was I'm like, what answer do you want? And I kept giving the wrong answer, and then I'd realize, because they use weird words. So let me encourage you, is that encouraging? Let me encourage you that the real test will be multiple choice, and it won't be quite so weird. So when we get to a test on this chapter 3, you won't have to give all these like words and things. I'll just ask you, cosecant times cosine equals what? And as long as you can just find that answer, call it whatever you want, you're good, and you get points on the test, You know what I mean? So let me comfort you in your frustration. So basically the way it's going to work is it's hard to tell because I've filled it all in. But this was not filled in at first. This was. And anything shaded, in other words, these three things, I had to fill in myself. These two were multiple choice. So I'll go back and show you in a minute, but basically when you click on them, you have various options, and in this part, I just had to type in directly. It wasn't multiple choice, I had to type it in directly. So, in other words, what they're asking is they're saying, look, show that cosecant times cosine actually just ends up equaling cotangent. They want me to prove that. That's what this whole there's only 15 problems. That's a little bit nice. There's not too many of these because they're weird. So we're proving various identities. Things that are, when we say an identity, we mean two things that are identical, right? So this is actually identical to that. Cosecant times cosine is identical to cotan. Proving so is called proving the identity. So proving that they're identical. So how do you do that? Well, there's actually lots of ways. But what they ended up saying is, remember what cosine is? It's 1 over sine. You remember that rule? Oh, did I say the wrong thing? Cosecant? Cosecant is 1 over sine. I don't know what I said. But anyway, cosecant is 1 over sine. So then you just rewrite cosecant as 1 over sine. See how the cosine is still on the right? That hasn't gone anywhere. You see what's happening there? So that we just replaced the cosecant with 1 over sine. Kept the cosine there. And then, why does 1 over sine times cosine end up being cotangent? Are you aware of that? Yeah, because this, if I can get rid of all that I'm doing there, because this is really over 1, so this is putting them together, this is cosine over sine, 1 times cosine over sine times 1 is cosine over sine, which indeed is cotangent. So they're just asking you to remember all those identities. You get a 3x5 card on this third exam like on all the exams, so you can write down all the things that are important like that, like the fact that cosecant is 1 over sine, and the fact that cosine over sine is cotangent. You can have those. And again, on the exam, I would just say, hey, cosecant times cosine, what does it equal? And option B would be cotan, for example. You won't have to write the words, because the words are some of the worst parts for me. I know what I want to do, I just don't know what they want to call it. So I end up getting it wrong and asking for another one, and, it was a little frustrating. So I just want to be straight up with you about that. So anyway, so there it is in the end, all done. Let me show you. Let me go back and, that's the way it'll be in the test. Okay, so there it is. So they're saying, hey, tangent times cosine times cosecant equals 1. Why? Why are those identical? Why is the left side of the equal sign identical with 1? Why would that be? Well, which one of those is the right thing? Well, tangent is sine over cosine, isn't it? Yeah. So this one's not right, this one's not right, this one's good. So far, I'm down to 2 options. You with me? I'm rewriting the first piece, the tangent piece, as sine over cosine. So far, so good? So it's not B, it's not C, because they're already starting off wrong. They're writing it cosine over sine. That's upside down. Tangent is sine over cosine, huh? Okay, so it's either A or D. Let's keep going. Next comes the cosine. Well, yeah, that's true, of course. Next comes the cosecant. This is cosine. Next comes now. What's cosecant again? 1 over sine, not 1 over cosine. So there it is. There's our answer. It's D. Right, because see what happens? The sines cancel, and this is cosine over 1, so the cosines cancel. That's why it's just 1. Everything just cancels. Do you see that? Okay, remember, anything alone is really over 1, isn't it? Like a cosine alone is really the top. To be alone is to be in the top of the fraction, huh? Because you're over 1. So those cosines really cancel. You can cancel distant like that. I don't know if you're aware of that. That's totally fine. You know, top to bottom, far diagonal, close diagonal, it's all good. So the sines cancel, the cosines cancel. There's nothing left. It's just 1. That proves that it's true. All right, a little weird. So, yeah, this one's going to require a couple new theorems. Let me give those to you. Or I don't know if we've done this one before already. Sine squared plus cosine squared, well, I should say of x or theta or whatever, is 1. Have we talked about that one? Sort of, maybe briefly, just mention offhand. Well, now it's central. Now it'll be real important in this section. Sine squared plus cosine squared is 1. Why? Why? You know what? I can prove it to you really easy. You don't have to prove it, but I think you might be interested to know why that's true, and it's easy to see. Remember how whenever we do like any angle, you know, like we do the over and the up and that kind of thing, right? Say it's 30 degrees or whatever, and that means this dot is the x-coordinate is cos of 30 and the y-coordinate is sine 30. Remember how any dot on the unit circle, the x is cosine and the y is sine? The x is cosine, the y is sine. Remember that whole thing? So really that means the x, which is here, in this little right triangle, and the y, which is there, this x is cosine, and this y is sine, and that's a right triangle. So we could do the Pythagorean theorem, huh? And what's the hypotenuse in a unit circle? What does unit mean? It means 1. When we say this is the unit circle, we mean it is the 1 circle. That's what we're saying. Radius 1. Hypotenuse 1. Notice from the middle of this circle to the edge anywhere. Here it's 1, there it's 1. You know, if you go to the edge, from the middle to the edge anywhere, it's 1. It's a radius 1 circle. That's what we mean when we say the unit circle. Radius 1 circle. Okay, so what? Well then look, this over is cosine, up is sine, right? X is cosine, y is sine. That means Pythagorean theorem, a squared plus b squared is c squared. So over cosine squared plus up sine squared is hypotenuse squared, 1 squared. There's y. That's why that's true. It's just in any unit circle. Over and up. Sine squared plus cosine squared is 1 squared because of the Pythagorean theorem. Anyway, you don't have to know all that. You just have to put this on your 3x5 card. But not only this, from this, and this is super important, like we'll use this a ton in this section. Sine squared plus cosine squared is 1. So now, from that, you can derive 2 other formulas that are also very useful. If you divide through this thing by cosine squared, and that's okay to do, right? You can always divide through both sides of any equation, huh? So that's legal, that's true. If they were equal before and you treat them the same, they'll be equal afterwards, right? So what does that give me? What is sine squared over cosine squared? Tangent squared. Yeah, because sine over cosine is tangent, so sine squared over cosine squared is tangent squared. You with me so far? Does that make sense? Remember, right? Tangent is sine over cosine. So therefore, if you square both sides, same thing. Tangent squared is sine squared over cosine squared. So I can replace this with just tangent squared plus, what is cosine squared over cosine squared? Well, that's 1, huh? Okay, and then what is 1 over cosine squared? Remember what 1 over cosine is? Secant. So, you know, square it. 1 over cosine squared is secant squared. So there's another very useful and important theorem that we will use. So I got it from the first one by just dividing through by cosine squared. So there's 2 really important theorems that we'll use a lot. Let me get rid of what I did to get it, just so it's in its original form. well, let's erase the whole thing and rewrite it. So sine squared of x plus cosine squared of x is 1. So those two we will use quite a bit. You want to, and you saw how they came, right? I got the sine squared cosine squared equals 1 from the unit circle, then I just divided through by cosine squared and got the other one. So that's where those two truths come from, and we will use those two truths a lot. All right, let's come on down and say which, so what are we doing here now? We're looking at cosecant squared plus cotan squared is 1 plus 2 cotan squared. Now, why would that be? Oh, I got to give you one more formula. All right, I thought I'd done enough, but you need one more. This problem actually requires one more. Let me give you that one other one. I'll do it over here on the side. So, okay, so we've already talked about the, let me start with this basic one again. Sine squared of x plus cosine squared of x. Excuse me, I got the tangent squared thing by dividing through the top equation by cosine squared. You could also just divide through by sine squared, and you'll get another very useful formula. Right? First time I divided through by cosine squared, I got the tangent squared thing. Now I'm dividing through by sine squared. What is this? What's sine squared over sine squared? 1. Now what's cosine squared over sine squared? Good. Cotan squared, right? Remember cotan is upside down of sine, so it's cosine over sine. Remember that? It's upside down, so squared, same thing. Cotan squared is cosine squared over sine squared. Equals, and what's 1 over sine squared? Cosecant squared, because 1 over sine is cosecant, huh? There it is. There's the third one. So it's really those three that are very useful. See how we got them? I got the first one again, sine squared plus cosine squared is 1 from the unit circle. Then the other two, by just dividing the first one through by either sine squared or by cosine squared, you generate the other two formulas. They'll have us use those a lot. I believe that it's this one we need to use in this problem. Let's see. Going now we're ready. I think we're ready for the for the question. Cosecant squared plus, I'm just going to cut out the x, whatever. You know, I'm just trying to save room. So there we go. So there's what I'm trying to prove. That's what they're saying is true. These are identical. This is an identity. Cosecant squared plus cotan squared is 1 plus 2 cotan squared. Why would that be? Well, I don't know. Let me see. Could I replace this cosecant squared with something like right over here? What is cosecant squared equal to? 1 plus cotan squared, huh? So you could replace this right here with 1 plus cotan squared, couldn't you? Because this tells you so. You with me? Plus cotan squared. So you see what that's going to be then? 1 plus 2 cotan squared. Everybody see how I did that? I just used this over here and said, look, anytime you see cosecant squared, it's equal to 1 plus cotan squared. So anytime you see cosecant squared, you could replace it with 1 plus cotan squared because it's equal to 1 plus cotan squared. It's the same as 1 plus cotan squared. It's identical to. It's an identity, right? Does that make sense? So I said, okay, cosecant squared, I can replace that with 1 plus cotan squared. And then bring down the other cotan squared. And sure enough, that's 1, right? Then these are just like terms. Everybody see how I'm doing that? That's just like terms. Like, you know, 1 plus x is 1 plus 2x kind of thing. This is 1 cotan squared, which is 2 cotan squared, huh? Just adding like terms. Is that good? So now we know how to do that, but which one is it? A, B, C, or D? Which one did they do that same thing as we just did? See I did 1 plus cotan squared? Where do you see that? It's right there on D, isn't it? See how they did that on D? That's the right option. Is that good? It's different, isn't it? Very different. We won't do any more of this. This is the only really different, weird section. Just they want us to get used to all these, because you have to know a few of these. I mean, you can have a 3x5 card, but you got to get used to using a few of these important theorems, especially these three. These are really 3 important theorems. All right. You don't have to memorize them. Like I said, you get a 3x5 card, but sometimes it's just helpful just to have them right there. So here's a way to help you. You know, sine squared plus cosine squared is 1. That one's fundamental. You want to just know that one because it comes up all the time. And then the second one, tangent squared plus 1 is secant squared. Notice that these two are the same thing if you just take that one and you put cos on them. Right? If I go cotangent squared, that's what this is, 1 plus cotangent squared, is cosecant squared. That's it. See how these two are the same thing? This is just the co version, that's the non-co version. That just helps you remember it. And then sine squared plus cosine squared is 1. That's really foundational. So let me put it over there with the little option displayed. It's a better way to do it. All right. So yeah, so there we go. So they want me to put something in that box, and then they want me to choose one of these multiple choice reasons why I can put that thing in that box. All right, so do you see what they're doing? They're wanting me to replace the cosine with something, aren't they? Yeah, which is weird. Why do they want me to put, I don't know. Anyway, but does everybody see they want me, I wouldn't do it that way. But anyway, they want me to replace the cosine with something. Everybody see that? Right? Because, you know, they got the secant, got the cotangent, got the cotangent, and the cosine is being replaced with something. Okay, what? What can you replace the cosine with? I don't know. See, I wouldn't do the problem that way. That's a weird way to do the problem. That's why it irritates me. They kind of force us to do it their way and think their thought, which isn't really how I would have done the problem. I would replace that secant with 1 over cosine. That's what I would have looked here and said, look, that secant, he's 1 over cosine. That's what I would have done. And then canceled those cosines on the top. But anyway, they didn't think that way. So I got to think their thoughts. So what is, I guess I could put 1 over secant here, huh? Because cosine's 1 over secant. That's probably what they're doing, which to me seems backwards, but okay. Right, everybody with me on that? Right, because remember, 1 over cosine is secant. Likewise, 1 over secant is cosine. They're upside down of each other, aren't they? Cosine and secant, right? Upside down. So I believe, I'm guessing, that's what you can't ever tell till all the steps are laid out. So I just telling you in advance, you're going to get these wrong a million times, but you can ask for a new one. After you've seen it, then you go, oh, I see what they want. All right, give me a new one, and then you can play their game. You're going to probably have to do that a bunch. Anyway, I think that's what they're saying. So which one of those words, let's read through the words. Separate the quotient into 2 terms.
Apply reciprocal identity.
Yeah, I agree. It's apply reciprocal, yeah. Because these are reciprocals, aren't they? Upside down. These are reciprocal identities. Yeah. You know, something's upside down or something. Yeah, apply reciprocal identity. I believe that's it. I say it that way because, you know. Okay. So here we are, number 4. If you guys could just whisper a little bit quieter, please. Thank you. All right, so we get to here. So now these tangents will cancel basically, won't they? Just going to be 1 on the top. Does that make sense? What's going to happen? Now, what's that called? I don't know. It's just called canceling. They want me to do some like fancy name to it. That's where it kind of bugs me. Like, what do you mean? What's it called? You just cancel. Apply a quotient identity. I don't think so. Apply Pythagorean. No. Divide out the common factor. I guess that's what we're doing, right? Apply a reciprocal. Now, it's got to be the divide one, right? I guess that's such a fancy way to say that. You cancel. Can't they just say cancel? But anyway, I think that's what they're talking about. And it just does that. All right. So, okay, so why would cosine times cotan be that big thing? I'm not sure. We could replace, okay, looks like, I'm looking down at the options here. Looks like they're trying to replace the cotangent piece with something, huh? So which one of those is the correct replacement for the cotangent piece? What is cotan equal to? Cosine over sine, right? So that'd be this one, right? The other two are wrong, aren't they? Yeah. Part C. That was easy. Part C. Now, I want to explain more to you, though, about the rules because on the test it's multiple choice and it just goes to the final answer. So why would, so you do need to know. Like what I mean to say is on the test, guys, I won't even give you this. I'll just say, hey, cosine times, I mean, I will. It'll be one of the answers, though. It'll be like, is it answer B? Is it this? Or is it something else? So you will need to know the rules for what cosine times cotan is. So cotan is cosine over sine. We know that. So it's this times this. We good to there? But why? Here's what I wonder if you know or don't know. Why would these two things multiplied? I assume we're good to there. But why would those two equal that? Do you see why this stuff would equal that stuff? Why would that be? Well, let me help with that. Let's take it over here. We have cosine times cosine over sine, like that, which is, now what do you do with cosine times cosine over sine? I think they're leaving out a couple steps in between that would be helpful to show. So, over 1. Remember, anything alone is over 1, right? It's really in the top, so it can't cancel that cosine. Right, it's in the top, so it's actually going to be cosine squared over 1 times sine is just sine. Good so far? Now, what in the world can I do with cosine squared? Well, remember that most important, I mean, it's really almost the most important thing we'll use in this section. Sine squared plus cosine squared is 1. We'll use that again and again and again. I could solve for cosine squared here. If you move the sine squared to the other side, what happens when something moves to the other side? Changes sign. I'm just subtracting sine squared from both sides, basically. You good there? So cosine squared is the same as 1 minus sine squared. So anytime you see cosine squared, you're free to replace it with 1 minus sine squared. So right here, I can replace that top with 1 minus sine squared, which is what they did. You see, that's what they did. So I think they should have shown those two steps, but they just jumped right to here. Is that okay? See how they're doing that? So we use this sine squared plus cosine squared as 1 a lot. A lot having solved for one of the pieces, like solve for cosine squared or solve for sine squared and plug in. That kind of maneuver happens quite often. Very common. Is that okay? Questions on that one? Another tough one. So, all right, so as I look, why would this equal that? Why would that be the case? Well, here's what I would think in my head. I would think, look, I need to go from one fraction to like two separate things, plus and minus, some minus in particular, right? Two things subtracted. How do I do that? How do I go from like one fraction? That's the main thing that's striking me in the difference on the left side and the right side between the structure of the left side and the structure of the right side. The right side has like two separate things with a subtraction. How do you make like one fraction become two separate things? It's again going to be that sine squared plus cosine squared equals 1. How do I know we're going to use that? Because you see, if I take that way, and also I'm looking at that sine squared. I'm looking at that sine squared at the top and thinking, I need to replace that sine squared with something that's two things. What do I have that does that? Oh yeah, this guy. If I jump the cosine squared to the other side, then sine squared is 1 minus cosine squared. I could replace that top sine squared with two separate things subtracted, which is kind of like where I seem to need to head on that right side. It's like the structure of the right side. That's why I'm thinking of it. See how? So these just take practice and familiarity, with these theorems, and then pretty soon you're like, oh, I see, it's going to be. So whenever you see sine squared or cosine squared, you should think of this theorem. It's the most important one in the section. So, okay, so how will that work exactly? Well, that means I would take that top sine squared. Let's take it piece by piece. I'll bring it down here. Take that top sine squared over cosine. That top sine squared is the same as 1 minus cosine squared. Good so far? Now, okay, and what can you do from there? Well, you can break it up with a common denominator. You guys know common denominator with any fractions, right? I can break it up. Like that, huh? Because that's common denominator. You can make the 2 into one fraction or 2, either way, depending on what you're trying to do at the moment. You see that? And then what is 1 over cosine? Secant. See, I'm almost there. What is cosine squared over cosine? Cancel. It's just cosine. Right? Because cosine squared here was cosine. Right? So, boom. Just cosine. That's it. Do you see that? See those steps? And that just takes practice, familiarity with the theorems. So again, I saw sine squared, and I thought, oh, it's got to be sine squared plus cosine squared. Well, that's almost always what you use when there's sine squared or cosine squared anywhere. So replaced it with 1 minus cosine squared, broke it up over common denominator, and then that's secant. This cosine squared, so it's just cosine. Now, how do they say that? I have no idea. They say a bunch of weird stuff. So you got to go back and click. I'm tired of going back and playing their game. I'm sure you will be too. But can I just leave that and say, there it is. However weird way they say that, those are the steps you want to go through on that. All right, well, we better move to our test on that note.